All right, let's dive into one of the most famous, most bizarre, and honestly, most important experiments in the entire history of science. We're talking about a test whose results were so strange, they didn't just surprise scientists, they completely shattered our understanding of reality itself.
So it all starts with this fundamental puzzle. For centuries, we've been asking, what is all this stuff around us actually made of? The basic building blocks of our universe. Are they tiny, solid objects, or are they something else entirely?
And that really brings us to the core question, the big mystery we're unpacking today. When you look at the tiniest things, like an electron or a photon of light, what is it? Is it a particle? Is it a wave? Or is it somehow impossibly both?
To get our heads around this, just think about these two ideas, right? On one hand, you have a particle. It's like a tiny marble. It's a solid little thing. It's here or it's there. It can only be in one place at a time. Then you have a wave. Think of a ripple in a pond. It's spread out, it's everywhere at once, and it can interfere with other waves. Logically, it just seems impossible for something to be both of those things.
So, to finally settle this argument, physicists came up with this brilliantly simple experiment. It's called the double-slit experiment, and the whole point was to force nature to show its cards. Is it a particle or is it a wave? This test was supposed to give them the final answer. And the logic is super straightforward. If you shoot marbles through two slits in a barrier, you get two distinct lines of marbles on the wall behind it. Makes sense. But if you send water waves through those same two slits, the waves interfere with each other, creating this complex pattern of many stripes. So the rule is simple. Two bands means it's a particle, an interference pattern means it's a wave. Easy enough, right?
Okay, so what happens when we swap out marbles for something quantum? Physicists decided to fire electrons, which everyone assumed were just tiny little particles, through the same setup. They were expecting to see two simple bands on the back wall. Well, what they got was something else entirely.
And just to be absolutely sure, they slowed it down. They fired the electrons one at a time. So there's no way they could be bouncing off each other. But as the pattern slowly built up on the screen, something that should have been completely impossible started to happen. This is the first, just completely mind-bending twist. Instead of the two bands you'd expect from particles, the electrons created a wave interference pattern. I mean, let that sink in for a second. This happened even when they were sent one by one. How could a single electron, all by itself, create a pattern that requires something to interfere with? The conclusion was just inescapable. As bizarre as it sounds, the only way for this to happen is if each individual electron went through both slits at the same time, acted like a wave, and then interfered with itself. I know, it totally breaks our common sense, but the evidence was right there on the screen. But believe it or not, the mystery was far from over. This is where it gets really weird. The scientists were totally baffled, so they decided to get clever. They thought, okay, fine, we'll just watch. We'll put a tiny little detector right by the slits to see which one the electron actually goes through. It's kind of like they were just politely asking the universe, excuse me, could you just tell us which slit the electron goes through? A totally reasonable question. All they wanted to do was peek behind the curtain. But as it turns out, the universe does not like being watched. And here it is. This is the absolute climax of the experiment. The second they turned on their detector to observe which slit the electron went through, poof, the interference pattern completely vanished. Gone. And instead, they got two simple bands, just like the marbles. So, when they didn't look, it was a wave. When they did look, it became a particle. This reveals something just incredibly profound about the universe. Observation, in the quantum world, isn't a passive thing. The very act of measuring which path the electron took forced it out of that weird, wavy state of possibilities and made it choose to act like a particle and take one single definite path. So, what does this all mean? This experiment didn't just confuse a bunch of physicists. It forced us to completely rethink the very nature of reality itself. It suggests that on the most fundamental level, things just aren't as solid and certain as they seem. And this wild idea actually has a name. It's a core concept in quantum mechanics called superposition. It's the idea that before you measure it, an electron isn't in one place or the other. It exists in a state of all possibilities at once, a sort of wave of probability. It's going through both slits and neither, all at the same time. And this is the really big, mind-blowing takeaway. Our act of measuring, of just looking, seems to be what collapses that wave of possibilities into a single concrete reality. It's as if, until we look, the quantum world is just a smear of potential. Which leaves us with this final, really unsettling question to chew on. If the quantum world only snaps into a definite state when it's observed, what does that say about the universe when we're not looking? Is reality itself just waiting for an observer to bring it into existence?